We can continue the number line to see negative numbers. Whole numbers and negative whole numbers are together collectively called the integers in mathematics. And for that, we can see if we just add a 0 here in the beginning, if we go to the right, then we know we have 1, 2, 3, 4, 5, and 6. And of course, that continues on indefinitely to the right. But if you go to the left, we're going to get negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. And of course, that continues indefinitely to the left. All types of numbers can be negative, fractions, decimals, percents, all those kind of things. And so we can show 0, and then this is going to be 1 here. And this is going to be 1/5, 2/5, 3/5, 4/5, and of course 1 is the same thing as 5/5. These are also the same thing as the decimal 0.2, 0.4, 0.6, and 0.8. Going to the left, we're going to have negative 1/5, negative 0.2, negative 2/5, negative 0.4, negative 3/5, negative 0.6, negative 4/5, negative 0.8, and finally negative 5/5, which of course is equal to negative 1. And that of course continues on indefinitely in both directions. We can order this number by always keeping in mind that numbers to the right are greater. And it doesn't matter what sign is there. It's always, as you go to the right, you get greater and greater numbers. So here we can see that if A is here on the number line and B is here, then A is less than B, or the same thing as saying B is greater than A. So if like 0 is right here, then we could say that this is 1, 2, 3, right? And A is 2, or negative 2, because it'd be negative 1, negative 2. You could also replace this and move 0 over here. Then here A is 2. If I were to count this by 1, 2, 3, 4, 5, 6, 7. So of course B is greater than 7 is greater than 2. B is greater than A. And likewise, if I just move 0 all the way over here, in this case I have B equal to negative 3, negative 4, 5, 6, 7, negative 8. B is negative 3. That's greater than A being negative 8. Doesn't matter which numbers they are. You can of course, make this make these in like negative 0.1, negative 0.2, negative 0.3, 4, 5, 6, 7, negative 0.8. Still, negative 0.3 is greater than negative 0.8 because all that matters is that as you go to the right, you have bigger numbers. It can help to think of this in terms of money, that if we have 0 here, then as you go to the right, you can kind of think of it as like that's the more and more money that you have saved in your checking account, for instance. And as you go to the left, that's the more and more money you have owed. And if you were to ask the question, which would you rather have? You'd rather have more this side, you have more saved, than more this side, having more owed. It's also important to note that it's not really in terms of smaller, like these are not smaller numbers and these are bigger numbers. That's not the right way of thinking about this. The best way of thinking about this is that these are small numbers that are close to 0. The closer and closer you are to 0, the smaller, quote unquote, smaller numbers you have. And as you get further and away from 0, you have larger positives and larger negatives. I'm just talking about ordering the numbers. We have to have some ordering fashion. And that fashion is that as you go to the right, you have greater numbers. And as you go to the left, you have lesser numbers. Okay, so we can, of course, order these numbers from smallest to greatest. We can just do this using a number line if you'd like. We have here negative 4. So I'm going to put, these all be negative. So I'm going to put 0 here. Negative 1, negative 2, negative 3, negative 4. That one's right here. Then negative 12 over 6 was the same thing as negative 2, right? 12 divided by 6 is 2. So negative of that would be negative 2. That's right here. Negative 6 is right here. Negative 2, well, that again we have right there. and then -3 is right here. So the least to greatest, that's ordered from left to right, is going to be least to greatest. The least one's going to be -6. Then it's going to be -4, -3, and finally we have two -2s. So I'm just going to put them both right next to each other. Okay, for this one we have fractions. Let's do the same kind of thing, and this one's over 1. The rest of these are less than 1, so I'm going to write it like this. I'm going to draw 0, 1, 2, and then -1 here. Okay, so for this first one, we have 1/3. That's going to be 1/3 of the way up to 1. This is 1/3 here. So there's the first one. 3/4 is going to be half, and then 3/4 is about right there. -3/2. Oh, that's actually less than -1. So it'd be -2. -3/2 would be right around there. -4/3. I was thinking that this was +4/3, but it's -4/3. That's actually going to be a third of the way past 1, which would be about here. If I were to cut this into thirds, be like this. Let me make this a little bit smaller here. -4/3 is right there. And finally, -1/8. So that's going to be 1/8 of the way past 1. So this is half, a fourth, and an eighth there. So this is going to be -1/8 right there. So from least to greatest, we're going to start here. -3/2 is the smallest. Then we have -4/3. Then we have -1/8. Then we have 1/3. And finally 3/4. And of course, it's an easy way of checking to make sure that all of your positive numbers are bigger than or greater than your negative numbers, because that's always going to be the case. Okay, hopefully you see a pattern here that the bigger negative numbers there are, they're always going to be least in order. So here we have, this is the biggest negative number here, so that's going to be the least. The next biggest is going to be this one. The next biggest is going to be this one. Then this one. And finally, this one here. So as you go to the right, you get more and more positive, or it's getting closer to the positive numbers. That's least to greatest. But I want you to think of this as smaller negative numbers and bigger negative numbers. Okay, for this one might be a little bit confusing because we have all of them being points and then zeros, but really what we're looking for is numbers that are least to greatest, and that's going to be the bigger negative numbers are least, and the smaller negative numbers are greater. So -1.5 is going to be the first one. Then we're going to have -1.05. This is the same thing as 3/2. This is just a little bit past 1. Here, the next one's going to be 0.5, -0.5. Then we're going to have -0.05. And finally, this number here is closest to 0. It's the smallest negative number in this list. So it's going to be closest to 0. Once again, you can just pull out a number line here and look at them, right? If we had 0, 1, and then 2, negative, I should say here. -1.5 would be right here. -1.05 would be somewhere around here. -0.5 would be around here. 0.05, this is going to be -0.1, and fifth of that would be right around here. So that one's right there. And finally, this one's very, very close to 0. And that means it's further to the right. Of course, the context that we're talking about is going to determine how to interpret the negatives and the positives. So here we have in Camden, South Carolina, we had a record low temp of -19 degrees Fahrenheit on January 21st, 1985. In Monahans, Texas, had a record low temp of -23 degrees Fahrenheit on February 8th, 1933. So we're going to use a number line here to compare which one is lower. Well, I don't have enough space here to go all the way down to 0, but 0 would be somewhere over here. And then we're going to go down, right? This would be negative 10, 11, 12, 13, 14, 15. I need to go a little bit further than that. Let's say this is negative 15 here. Then we have negative 16, 17, negative 18, negative 19. Well, that's this one right here. It's Camden, South Carolina. I'll do South Carolina like this. Negative 20, negative 21, negative 22, negative 23. And that is this one here for Texas, for Monahans. And now you can see, well, which one's greater than, right? It's going to go like this. This is a greater temperature than this one is. So South Carolina, Camden, South Carolina had a warmer, quote unquote warmer. They're still going to be cold, right? But negative 19 is comparatively warmer than negative 23 degrees Fahrenheit. So, so this was warmer and this was colder in this situation. Okay, and then if we're going to talk about Tom lost 52.50 gambling, that means we're going to, a way of representing this number would be negative 52.50 because he gave it up. He lost it. If Larry added 25 songs to a playlist, that means it's going to be plus 25 songs. It's in addition. It's increasing how many songs are on the playlist. An airplane descended 500 feet. That would make sense to make it negative 500 feet. And a solar panel adds 161 kilowatts to a grid. So it's going to be plus 1.61 kilowatts. A checking account balance, that means that's how much is in your account. That means it's going to be a plus 235.34. Whereas a credit card balance, this is how much you owe. So this would be a negative because it's how much that you need to get rid of, or how much that you've given up to do whatever kind of purchases on the credit card. If the water temperature dropped 13 degrees Celsius, it would make sense to make this a negative 13 degrees Celsius. And if Ruth earned $675.23 at her job, that makes sense to be a positive $675.23. Though, of course, this one's interesting to think about because if you put it from the perspective of the business side, right, the business would have lost $675.23 giving it to Ruth. Of course, then you can make the statement that the business gained money based on Ruth's work. That kind of whole thing is really just relative to what you're talking about. That's when pluses and minuses are used. Okay, what is the percent change if a car's original MSRP is $18,200 in 2014 and the Kelley Blue Book price 8 years later is $77.57? So percent change, we always think of it as final divided by initial. Well, the final is going to be the later price, which is $77.57, divided by 18,200. So I'm going to use a calculator for this to get the percent. And I'm getting 0.4262 or 42.62%. This is not a percent change, right? To do the percent change, what we should do is subtract this, subtract 100% from this number. So I'm going to take this minus 100%, and that gives us the percent change of negative 57.38% change. And so what this means is that you can either think of this as a negative 57.3% change, or the car depreciates by 57.38%. The negative in this case is in the word depreciation. That means it's going down in value. So you can either think of it as a percent change, positive or negative. And to do that, you always just find this value, then subtract 100% from it. And that will give you either a positive or negative. That's your percent change. Or you can just think of it that we're decreasing in value. And so 57.38% was lost over just this period of time of 8 years.